What's happening, folks? Geologist Philip Prince looking out over Mount Mitchell, North Carolina, the highest mountain in the entire Appalachian Range, 6,684 feet above sea level. If you're watching outside of the U.S., it's just a little bit over 2,000 meters above sea level. Higher than anything anywhere else in North Carolina, Tennessee, and even all the way up into New England. But an interesting question with a high mountain like this is getting to the top. If you hike to the top, is it also the biggest climb that you can find anywhere in the Appalachians? In other words, does Mount Mitchell rise up farther above its surrounding valleys than any other mountain? There is a really cool hike you can do. It starts somewhere down here and kind of goes up like this to the top. Pretty imposing. I don't think you can even do it right now after Helene, but you end up climbing a bit over 3,000 feet in several miles of hiking, and it's a pretty good one. So a few years back, I got interested in this question, wanted to actually make some measurements and figure out where the biggest climb would be in all of the Appalachians if you didn't take a zigzag course like that. If you just went to a spot and man, just straight lined it all the way to the top, where would your biggest climb be? As it turns out, it's not Mount Mitchell. In fact, not at all. You don't even have to go far to find a bigger one. Just take yourself down the ridge a little bit over here to Cattail Peak, and at Cattail Peak, if you measure out just a couple miles, my reference point initially here was about 2.5 miles from the summit. You can climb about 3,700 feet down here from the Tow River to get up to the top of Cattail Peak, right? So that's even bigger than Mount Mitchell because Mount Mitchell's just a little bit farther away from those lower river valleys down there. But as it turns out, this is not the best you can do in southern Appalachia, and it's also not the best you can do again within the entire Appalachian mountain range. Now, what does this sort of measurement scheme look like? Talk about that real quick because I haven't actually done this. I don't know if people have. I think it's kind of an interesting idea, but if you could find, a way to get out to these mountains where you had national forest, kind of public land, whatever, where you weren't walking over anyone's property, the idea would be that you would look at a high mountain peak, have yourself kind of a radius like this and find the lowest point somewhere in there and kind of straight line it up to the top, right? So that's how these measurements are made. But as it turns out, the in the case of Mount Mitchell and the Black Mountains here, they're really, really high in terms of their elevation, but the valleys around them are also pretty high because you're really nestled deep in the Appalachians here. And to get a sense of what that means, zoom out here just a little bit, and as we zoom out, start to see some other mountain ranges around it that are also kind of notable. Now, here in southern Appalachia, you can tell when mountains are really, really, really high because they're going to look really, really dark on their summit. So there's the Black Mountains where Mount Mitchell is located. Got the Roan Mountains over here with these fir and spruce trees growing on top of it that gives it that dark color. The Roan Mountains there also well above 6,000 feet in elevation, but it has the same problem as Mount Mitchell in that the valleys around it are also really high. They're a little bit under 3,000 feet above sea level, so it limits that elevation difference. Now, a good way to see this is to take some of these colorful digital topography maps that I like to use that actually color code the landscape by its elevation, right? So white areas are really high, brown is a little bit lower, the yellow color is lower yet, and by the time you get down to the greens and the lighter greens, you're down under 2,000 feet above sea level. And when in this view here that you're looking at, as low as about 1,000 feet above sea level, right? So this is a quick way to see where those white high elevations are located, but it's also a really good place to see where you've got those higher elevation valleys that are keeping that overall elevation difference kind of low. So everywhere that we just looked there, yeah, you got some big mountains over in this area, but you're never going to get that sort of maximum topographic relief and that biggest climb anywhere in the Appalachians. So where do you see this? Where do you go for the most bang for your buck? The biggest mountain that you can get east of the Mississippi. I've not even produced this video yet. I'm sure somebody from Colorado or something's already like, well, that's not very big. Yeah, I hear you. We got forests and humidity here, so everybody's got their own thing. Right now, just right around the middle of the screen, you're looking down on it. The biggest climb anywhere in the Appalachians will allow you to ascend about 3,900 feet in 2.5 miles. But if you stretch that distance out to right around 6 miles, you can actually climb vertically over a mile, about 5,300 feet. That mountain's Mount LeConte at the end of the black arrow there, and you could do that climb up out of Gatlinburg, Tennessee. There are hiking trails that would allow you to do that, and what that would look like on the map here would be something like what I've drawn right there. That would be your route. That line would be approximately, again, 6 miles long, and the elevation difference there would take you from maybe just a whiff under 1,300 feet above sea level to I think LeConte is 6,593, just under 6,600 feet above sea level. So not quite as high as Mount Mitchell, not far off of it though, but it just happens to be very close to these much lower elevations that you get out here in the valley and ridge, actually where the Tennessee River is taking shape there. So this is it's kind of a cool thing to consider. And again, I don't know if anyone has attempted this as an overland route. You might actually be able to do it because you would be largely within, I think, the Great Smoky Mountains National Park here. But this is this is better than anything that you'll do even in New England over this distance, and you're certainly not going to find it anywhere else, anywhere in the Southern Appalachians. Now, I keep mentioning New England because you got the White Mountains up there. New Englanders, if you're watching this video, don't worry, we're going because you've got your own kind of champion up there with Mount Washington as well. But the overall idea here is that for a mountain to have that maximum topographic relief, that maximum size, you need the big mountain, but you also need pretty low valleys next to it. And when you look out across the landscape here on the edge of the Smokies, there's a really big change, of course, in the colors you see because the elevations change, but there's just a shift in the overall grain of the landscape. I mean, you're looking at something just totally different out here in these low valleys. So if you went from Gatlinburg down past Pigeon Forge and out into this much flatter landscape, not only are you leaving the high mountains in terms of the landforms, you're also changing geology. And that's really the explanation here. I guess part of the interest in this video and this question is why is this biggest possible climb right here at Gatlinburg? And ultimately it comes down to thinking about how the Appalachians are assembled. So I'm gonna draw out kind of a classic style of drawing here for this YouTube channel. Talk a lot about the Appalachians. You're going to be drawing something that looks like this quite a bit. Iconic mountain range, one that has sort of informed the study of younger mountain ranges around the world, largely because what you're seeing in the Appalachians is what's still deep inside the earth in mountain ranges, like the Himalayas is a good example, right? So we got the big mountains right here, no problem there. What's under those big mountains? It's going to be different rock. And the diagram that we're drawing out here again is a very simple one, but it's going to give you just sort of the overarching idea of what controls that sudden change in the landscape there and why, as you make your way out again towards Pigeon Forge, for example, you're going to end up seeing not only a different landscape, but if you were to look at the rocks in the road cuts out the window, they look quite a bit different too, right? So I'm going to do maybe just one more kind of a subdivision there. And we're going to color code this because those colors are going to represent different rock types. And that's ultimately sort of the answer to our question here, right? So what are we labeling here? The purple, Sedimentary rocks dominated in this part of the Appalachian by limestone and dolomite. That's good at making caves. It's really bad at making high elevations in this part of the mountains, right? So if we start drawing in some mountain topography here, there's going to be our huge, very rapid jump in elevation right there. Got an even higher mountain back here associated with this same type of rock, but you'll notice it's not right up at the edge of the mountains towards where that purple stuff is exposed at the land surface, right? Kind of telescoped everything. This is going to be our Blue Ridge escarpment back on the other side of the Appalachians here. We'll fill in a little bit more mountain topography here, but we already got the part there that we're really interested in. Now, when you're looking out here into the sedimentary rocks, in terms of mountain height in this part of the Appalachians in particular, it's just not gonna compare. So we'll fill in some small ridges here just to make the valley and ridge live up to its name, and then we're gonna be pretty well good to go here. Fill in a little more of that geology underground as well, because that's going to be a big part of the story here. All right, so there we go. Where's your biggest mountain here? Well, it's going to be the one that is underlain by the brown rocks there, which geologically is the Great Smoky Group. It's a really, really thick sequence of rocks. A lot of the rock is sort of like the rock quartzite, really strong, hard stuff, really tough to erode away. And in this particular case, in this part of Appalachia, it's been kind of stacked and folded up on top of itself. So there's even more of this really crazy hard rock. Now, the second part of this equation here is what we're going to highlight now. It's these ancient thrust faults that have sort of stacked these rock sequences on top of each other to produce the Appalachians as we see them today, sort of an eroded remnant of what they used to be. That thrust fault, which has the thick black line on it there, has brought that huge, massive accumulation of Great Smoky Group rock into contact with the purple stuff here, the sedimentary rocks of the valley and ridge. And because those are so much easier to erode, they weather away in our humid climate here in the Appalachians. They're going to have a very hard time producing any kind of elevation. At the end of the red arrow, you have a huge amount of the toughest stuff around, and that is going to give you this huge sudden step in the landscape because it's such a drastic change in rock type. And not only is there hard rock there, there's about as much of it as you'll see anywhere within the overall range, right? So what about back here? Well, you got another mountain back here. That one can be even taller than the one that is at sort of the leading edge of the brown there, but it's going to be set further back into the mountains and it's farther away from these low elevation valleys, right? So the thing about the Smokies that makes them so impressive and the reason that they host this kind of superlative mountain for the whole Appalachian range is all coming back to that sudden change in geology there across that thrust fault, right? So we added some rivers here, sort of an interesting way to think of it. Rivers coming down like this out into the valley. Back here at our high mountain, this river would have to flow a tremendous distance and step down a really long way to finally make its way out here into the Tennessee Valley, right? The river here that's coming down our biggest climb to the front, it's got much closer access to those low elevation valleys. So it's going to sculpt that topography really sharply and keep that big mountain really steep there. Now, without my big accumulation of this brown Great Smoky Group rock here, yeah, you're still going to have big mountains along the edge of what we call the Blue Ridge, which is going to be, as you see, at the right side of that big heavy black line. But the overall elevation difference just isn't going to be as large. So when you are seeing this incredible landscape here with the really incredible and sudden change in elevation that makes this, in terms of how far you can climb, the biggest mountain anywhere east of the Mississippi, you're very much seeing the geology of the Appalachian Mountains, right? So it's kind of a cool way to think of it. And the world over, high mountains are high for a geologic reason, but here in the Appalachians, it's almost always coming down to the rock type. Is the rock under the mountain especially hard, and is there a particularly large amount of it under the mountain that sort of protects that mountain from erosion, right? So, grand champion there from Gatlinburg to the top of LeConte. 5,300 feet in just under 6 miles. If you went out to Pigeon Forge, if you stretched it out to 10 miles there, it's about a 5,500 foot change in elevation. Up there in the Black Mountains, Mount Mitchell, the best you're going to do over a 2.5 mile distance is a little under 4,000 feet. And if you stretch that out to 5 or 10 miles, it's not going to increase much above that just because the valleys are so high in that part of the Appalachians. You can see Mount Mitchell right there. There's the top of Roan Mountain out there as well. Same problem, high valleys. And if you take yourself out to the edge of the Blue Ridge here, you just don't have any of the high peaks to sit next to the low elevation valleys like you do down in the Smokies, right? So, lest we forget, there's another candidate here that you absolutely have to consider. So we're going to start making our way north along the Appalachians. When you're here in the mid-Atlantic, Shenandoah National Park, for example, the highest peak there is just a bit over 4,000 feet above sea level. And in this part of the Appalachians, the biggest mountains that you're going to find in terms of elevation, they're actually out here in the Valley and Ridge or the Appalachian Plateau. You're looking at the Snowshoe, West Virginia area right there with that dark green, that spruce or fir forest, getting down towards places like Cranberry Glades, where you're looking right there. These places are also on really hard rock, but in the mid-Atlantic, still the Appalachians, the geologic structure and the structure of the Earth's crust is actually a little bit different, and it's just not as good at holding up high elevations. We'll keep going north. Iconic, beautiful Pennsylvania Valley and Ridge, awesome looking mountains. They're not particularly high in elevation. We're still going here. Got the Adirondacks there off to the left. There are some high elevation mountains there. The maximum elevations aren't getting up into those 6,000 foot ranges. And of course, here you're still pretty insulated from the ocean. But right in the middle of the screen, you can actually navigate to it because it's easy to see from Google Earth because there aren't any trees on it. Got the highest peaks of the White Mountains in New Hampshire right there. So if you are by chance watching from that part of the world, you've made it this far. I've talked all about the Southern Appalachians, and you're like, why aren't you talking about the whites? Well, here we are, and they absolutely deserve a mention because over the shorter scale, if you were to go from the summit of Mount Washington, 6,288 feet above sea level, if you were to go out 2.5 mile radius from that, you can actually climb about 4,200 feet, which is a few hundred feet more than you can do to Mount LeConte. So at that shorter scale, uh, Mount Washington here in the Whites is actually the champion. And if I'm not mistaken, when I measured this up, that straight line distance would be coming from this side down out of Pinkham Notch up to the summit of Mount Washington there. What if you stretch this one out further? So 6,288 feet above sea level. That's pretty high, even by Southern Appalachian standards. Say we stretched out to 5 or 6 or even 10 miles. Interestingly, it falls just a little bit behind what you see down at Mount LeConte in Gatlinburg. And when I say a little bit, the difference would be over 6 miles, something like 5,100 feet of elevation change instead of 5,300. If you stretched it out to 10 miles, it would be something like 5,400 feet instead of 5,500. It's almost an insignificant difference, but it's just a tiny, tiny, tiny bit smaller over that large distance. But if you're thinking in terms of, planning one of these shorter but incredibly steep summit assaults, absolutely 100% you're going to get crazier stuff in the whites here. And if you're a person that has hiked in both areas of the Appalachians, both the whites and the Smokies, you know that when you're dealing with the whites, it's a different style of landscape. It's just a totally different experience. So what's the difference here? This one's sort of an interesting quick thing to address with a diagram down in the mountains of Western North Carolina and Tennessee. All of the terrain down there is sculpted by water. So all of your valleys there, all of your tributary valleys, they have this characteristic V shape, and the shape of the slope, or sort of the steepness of the mountain as you make your way uphill, it's sort of controlled by the steepness of these streams that are shaping the landscape, right? If you're in the whites, and this is something that you can very easily see from something like Google Maps terrain, the whites were glaciated. Um, and you see just sort of a totally different shape of valley here. In particular, you get these big, steep, sort of bowl-shaped kind of head wall valleys here. Plenty of big rock cliffs and exposures in them. Down further on the slopes, you have landscape features taking shape down here that are a little bit different. But in particular, kind of up in these parts, really high on the slopes, different ball game from what you're dealing with in water sculpted Southern Appalachia, and it all comes back to the glaciation, right? So you would imagine, in other words, in the geologic past, and in fact in the not too distant past, taking that big rounded valley with that big steep head wall, and you'd have to sort of fill that in to fill that in with a glacier, actually, which is kind of an interesting thing to do here. So something kind of like that coming down there. Big old ice sheet making its way out. We'll have some cracks up here at the top of it, right? So the landscape history of these places, again, entirely different, and you're going from having glaciers sitting on the landscape in the whites to these landforms that you see today, which are just so steep in comparison to what you see down here in the glacier, or the river sculpted part of Appalachia at the small scale. Once you stretch out pretty big, things even out pretty well. What do the whites look like if you zoom out even further? Well, at the end of the day, if you zoom way, way, way out here, the White Mountains are substantially closer to the ocean than anything in Western North Carolina or East Tennessee. So if you go all the way to sea level, Mount Washington is unequivocally the biggest mountain, or is associated with the most elevation difference anywhere in Eastern North America. The difference is over a distance scale like this, the mountain really doesn't have anything to do with the landscape that you see there on the ocean. So when you really get down to it, there are sort of superlatives or biggests, if you will, in both the Blue Ridge, the Southern Appalachians, and up in the Whites. It really just comes back to the physical distance scales that you're looking at here. Now, as a final thought, sort of a final perspective for those Western folks that don't very much like the smaller mountains on the East Coast. What do you see in an out west mountain range? Well, we'll go out to the Tetons. Good way to find that. Right in the middle of the screen, you got Yellowstone Lake right there. Really big lake that's pretty easy to find in Google Earth. Start zooming in, and we're coming right down on the Tetons right now. So this is a this is a big and steep mountain range right here. Really, really steep, really abrupt. If you were to measure the Tetons here in terms of that 2.5 miles from a summit, The elevation change there is about 6,500 feet over 2.5 miles. So that exceeds anything anywhere on the East Coast, including Mount Washington, by about 50%. So this is a whole different ball game out here. Yes, absolutely. The relief is bigger, the steepness is bigger, and that ultimately comes down to the fact that what you're seeing here is mountain topography that's associated with actively moving faults in the Earth's crust. We don't have anything quite like that east of the Mississippi, in terms particularly of faults that are actually shaping the mountains. All the faults that I talked about with Mount LeConte are ancient; they don't move anymore. So, in that sense, this is a different ball game. The tectonics are different, the geology is different, and as a result, the mountain topography is pretty different, right? So, if your friends get to arguing about the East Coast, yeah, there's a biggest mountain there. It just depends on how big of a scale you're talking about. Hopefully, after seeing this video, you can win that discussion. And if anybody out there has ever tried to straight line it from Gatlinburg to the top of LeConte, let me know. I would be very curious to hear your stories. I hope you found this video interesting. Hope you check out the next one when it comes along.